And so I'd say the biggest challenge that we approach in medical 3D printing that we're trying to solve is customizing designs for every patient. So every single person is a little bit different. And so by using computational design and 3D printing, we're able to create solutions that would be tailored for each person. And so on the left, you see one of the applications we work on is spinal fusion, where between two vertebrae, you would insert a 3D printed scaffold that mimics bone, and over time, it's going to trick the vertebrae into fusing together. And so this is for post-surgery recovery. And in order to optimize these solutions, we use this paradigm of material, process, and structure, where you can change the 3D printing materials for different properties. The processes you use give you different capabilities. And then where design comes in is how you use those materials and processes to create something novel and optimized for the user. And so in the lab, I like to differentiate our 3D printing into three major approaches. So we do extrusion, resin, and powder printing. So extrusion is what's the most common, where you're melting polymer through a nozzle. And so here we're able to create things like multi-material structures, which I'll talk to you a bit more about. Resin printing is photopolymerization. You can get a bit higher of a resolution here. So these you're seeing high resolution lattices with a methacrylic acid biocompatible material. And then one of the newer technologies is powder printing that's becoming more economically efficient. And with powder printing, you're able to create polymers like nylon that can be printed in the powder and supported, so you can have working mechanisms straight from the print. So we can see these rotational parts that we've prototyped in the lab. And so my lab, we really bring together these fields of medicine, mechanics, and manufacturing, and tie it together with the design process, where you could imagine you propose a design, and then you can model it and simulate it. And from that, you can create an optimization and then print it to actually test it in the real world. And what you learn from that process, you can go back and iterate and improve, or you can repeat that process over and over for different patients with different requirements.